in this episode, we are going to look at velocity and acceleration, which is part of the application of differentiation, velocity and acceleration. So let's assume we have a velocity v and we are given a distance x and a time t. So in differentiation, the velocity is going to be the rate of change of the distance. So let's define the term. This becomes our distance and this becomes what? Our time. And our velocity is going to be the change in the distance to the time. Are we good? And we know velocity, distance, meter per what? Second. So when we bring in the differentiation approach, it is going to be our dx on our what? The t. So the time rate of what? Change in the distance, which is the x, will give us the velocity. Are we good? Let's take a look at this diagram. Let's have this graph of time. This is our time. That's t against our x, which is the what? Distance. So if there's a movement from the origin to this point, then our velocity v, which is the change in the x, that's the distance, over the change in the t, will become the slope of this diagram. Are we good? The gradient or the slope of the diagram, this becomes change in x and this will be change in what? T. Therefore, change in x to change in t becomes our velocity. Are we good? So anytime we are given the distance, the change rate of what the distance now becomes our velocity. Are we good? It will be given in an equation form. We differentiate it with respect to our time or with respect to whatever we are going to differentiate with, and we will get our what? Velocity. Are we okay? So the first derivative of an x, let's assume of 2t squared plus t with respect to time. This is distance in terms of what? Time. Our dx, the t, will now be our 4t plus 1. This becomes our velocity equation. So we can determine the velocity at any given time. Are we okay? The same thing happens to our acceleration. So now we know that velocity is the dx over what? The dt of a given distance equation. What of acceleration? Acceleration is giving us the dv dt. That means after getting our velocity, the differentiation of the velocity now becomes our acceleration, which is the same as the second derivative of what? The distance equation. Remember, dv dt is the first derivative of what? The distance x. And the second derivative now becomes what? Our acceleration. So we saw this example. Our v was equal to 4t plus 1 because x was 2t squared plus t. The first derivative, which is dx dt, gave us this. Are we okay? Which is our velocity. Now, to get the acceleration, we have to differentiate the v with respect to t, which will give us what? 4, which is the same as the acceleration. And this is also the same as the second derivative of what? The x or the distance with respect to t. This is interesting and quite easy. Let's move through some examples and we move away. So example 1, the distance x meters moved by a car in a time t seconds is given by, so this is the distance. Remember, the distance x in meters is given by this equation: 3t cubed minus 2t squared plus 4t minus 1. Determine the velocity and acceleration when the time is 0 seconds. B, when the time is 1.5 seconds. Are we good? So with our solution, do we have our distance, which is the x? Yes. and it is 3t cubed minus 2t squared plus 4t minus 1. This is the distance. But we know that to get the velocity from this, we are going to get our velocity as dx with respect to what? The t. That's going to give us our velocity. And to differentiate this, we are going to get our equation to be what? 9t squared minus 4t plus our t, or our 4. How we go? So this is our velocity equation. Is the question interested in acceleration too? Yes. So to get the acceleration, we further differentiate this velocity. We know that acceleration, which is the same as the derivative of what? The velocity, which is also the same as the second derivative of the distance, will be. So we further differentiate this and we are getting 18t minus what? 4. This is our equation. So this is the acceleration equation. This is the velocity equation. Now we are to determine it when the time is 0. So first, at t equals 0, our v is going to be, this is the equation. So 9 square minus 40 plus 4. Very good. And with this, our acceleration is good, or our velocity is going to be 0, 0. So v is going to be 4 meter per what? Second. So at time 0, or the initial velocity of the car will be 4 meter per what? Second. Very good. The same thing at time 0, our acceleration from this equation is going to be 18 0 minus 4, and our acceleration is going to be negative 4 meter per what? Second square. B, when our t is 1.5 what? Seconds, then our velocity, the same equation, is going to be 1.5 square minus 4 1.5 plus 4. Therefore, our velocity with this is going to be 18.25 meters per second. And at t 1.5, our acceleration from its equation is going to be 18 1.5 minus 4, and our acceleration is going to be 23 meter per second square. So with this is the solution for our question. You determine your velocity, your acceleration with respect to the equation where velocity is the first derivative, acceleration is the second derivative, or acceleration is also the first derivative of the velocity. Are we okay? Let's check the example 2 and see how best we will analyze this. A particle moves in a straight line such that its displacement function is given by s in terms of that. Are we okay? Find velocity at t equals 3 seconds, time when velocity is 0, and acceleration when the time is 2 seconds. Are we okay? So now we have the displacement. Remember, displacement and distance are almost what? Interchangeable. Are we okay? So we have, it is given, the displacement or the distance is given in terms of what? S. Here, not the x, but rather s, and the equation is given like this. So can we write our equation, our displacement equation? And this is 4t minus 2t squared minus 5t cubed. Are we okay? Yes. So we have our displacement equation given, and we want to determine both velocity and what? Acceleration. So can I go through my differentiation? We know that the velocity is ds with respect to what? The t. Are we okay? And this is going to be the equation. If you differentiate this, 4 minus 4t minus 15t squared. This is the velocity equation. Since the question is interested in acceleration, can I also get my acceleration? Acceleration, which is also now dv dt, or now the second derivative of the displacement will be equal to, I'm going to differentiate this. So this will go to 0, negative 4, then minus 30t for the equation of the acceleration. And now we go, it says find the velocity at time 3 seconds. We have our velocity equation in terms of time already. We just input the 3, then off we go. So A, at t equal to 3, then the velocity will be equal to my 4 minus 4t, which is 3 minus 15 3 squared. Are you okay? So when you punch this on your calculator, your velocity is going to give you negative 143 meter per what? Second. Are we okay? And B, time when the velocity is 0. So we are now to determine the time when the velocity is 0. But do we know the velocity equation? Yes, this is it. So B, the velocity equation is given as this: 4 negative 4t minus 15t squared. So we are to find the time when v is what? 0, when velocity is 0. So can we say 4 negative 4t minus 5t squared should be equal to what? 0. This is a quadratic equation, right? So we can find the time. So can I rearrange it and make a better equation out of this? So this will be 15t squared plus 4t negative 4 equal to 0. If you rearrange this, you divide through by the negative, you are getting this equation. And when you punch this or solve this equation, quadratic equation, your t, your time, is going to be 0.4, or you have to get two values. T will be equal to negative 0.66. And since we are talking about time, it says the time, we don't have a negative for time, so this will run off and we are going to take the positive time. Therefore, the time when the velocity is 0 is equal to what? 0.4 second. Are we good? Try putting this into the velocity equation and you are going to get the velocity to be what? 0. Now B, acceleration when time is 2 seconds. And C, we have our acceleration equation here. A, which is negative 4, negative 30 t. Our t is 2, and we are going to get 30 by what? 2. Acceleration is negative 64 meter per second square. So this answers the example 2. It's quite interesting and very simple when it comes to the velocity and acceleration application. Are you okay? So you go through, you know how to calculate your stuffs. Example 3. This is quite interesting. A missile fired from ground level. Pay attention to this example. It contains some physics idea where we have to analyze things, but it's still application of differentiation. A missile fired from ground level rises x meters vertically upwards in t seconds, and x is given as this equation: 100t minus 25 on 2t squared. Now, find all these parameters. Are we good? So we are going to work out for all these parameters, and it's very simple. What do we have here? We have a missile which is fired from the ground, and its distance x is given this way. So we have to find the initial velocity of the missile, the time when the height of the missile is at maximum, the maximum height reached, the velocity when the time or the velocity with which the missile strikes the ground. So straight away, since I was given the distance, my distance x is given as 100t negative 25 on 2t squared. With that, are we okay? In the question, I am being asked of what? Velocity. There's nothing like acceleration mentioned. So since I'll be interested in velocity, can I say my velocity, which is differentiation of the x with respect to what? Time. And this is going to be 100 minus 25 what? T as the velocity equation. So this is now the velocity equation. And the first question is asking us, find the initial velocity of the what? Of the missile. How do we get the initial velocity? Now, a missile is what? Fired from ground level. So let's assume this is the ground level and there's a missile being fired up. So it is going vertically what? Up. And we are to find its initial velocity at the ground level. At the ground level. So meaning at the ground level, the time, what was the time? 0. Initial means it's now coming to a start, and we want the starting velocity, meaning t will be equal to 0. So if at the initial velocity t is equal to 0, then our velocity, this is the equation, will be 100 minus 25. This initial should give you the clue. And with this, our velocity is going to be 100 meter per watt second. So the initial velocity of the missile is 100 meter per watt second. Are we okay? Because we have our t to be in what? 0 for the initial stage. The time when the height of the missile is at maximum. Are we okay? The time, now we want the time at which the height of the missile is at maximum. Remember, this missile will come to a point maximum and now begin to what? Come down again. So we want the maximum what? Height. And from physics, we know that when we fire a missile up and it gets to its maximum height, at the maximum height, there is no velocity. The velocity is equal to what? 0 at its maximum height. So B, if at maximum height, you have to get this idea before you start. If at maximum height, our velocity is equal to 0, then we can get the time from the velocity equation. So we know that our velocity now is equal to 100 minus 25 t, and v is 0. We are going to get 125 t equal to what? 0. Are we good? So this is 25 t equals 100. And our t is now going to be 100 on what? 25. And we are getting 4 seconds. Are we good? So the time when the height of the missile is at maximum is 4 what? Seconds. Just know that at the maximum height, velocity is what? 0. Then the C says the maximum height what? Rate. The maximum height rate. It wants, so the question is asking us about the height, that's the length, the distance it covered to the maximum height, x. And we know that x will travel to the maximum height at this time of 4 seconds. Meaning if we put this maximum height time into the distance equation, we are going to get the distance it traveled from the ground to its maximum height. Are we okay? The maximum height occurs at t equal to what? 4 seconds. We saw at the B part that the maximum height occurred what? The time taken to reach the maximum height was 4 seconds. Therefore, the maximum height we are going to calculate will be at 4. So from the distance equation, which is 100t minus 25 on 2t square, our maximum height, which is the distance, will occur at 104, 25 on 2 by 4 square. And with this, if you punch, we are going to get 200 meters. Are we okay? So this is for the C part. The D part says the maximum velocity at, let's see what the C part is saying. It says the velocity with which the missile strikes the ground. So we want the velocity. So look at this. The missile will travel one way here, travel another way here. So we want the velocity at which it will start to move and now come back. The time taken to reach the maximum height at this end is 4. Therefore, it will take the same 4 seconds to come down. Meaning, if you want the velocity for both movement, the time is going to be 4 plus 4 here, and it is going to be 8. Are you okay? For 8 seconds. Therefore, the velocity at which it strikes the ground, we know that our velocity is 100 minus 25 t will be 8 now. 100 minus 25 by 8. And with that, we are getting the velocity to be negative 100 meter per second. Thank you for watching this episode. Watch out for the next part.